Hello and welcome. I'm Jonathan Hill, and I'll be your MC today. Today's webinar will introduce basic PMI concepts and demonstrate some possible workflows using NX. Our host will be Curtis Rands, who you might have met at the 2016 PLM Connection Conference in Orlando a few weeks ago. But before I turn it over to Curtis, let me give you a brief intro to ATA. Most of you know ATA either through our role as a Siemens partner and reseller or through our robust engineering services. It's our experience in providing engineering services across a wide range of industries that allows us to put the value-added in value-added reseller. We're solving many of the same issues in the same industries as our software customers, which allows us to provide exemplary support. On the services side, our focus is on analysis and test-driven design. Whether it's performing ground vibration tests on state-of-the-art aircraft, analyzing the next generation of spacecraft and planetary rovers, or helping to ensure the safety of roller coasters and other entertainment park attractions, ATA is here to help our customers meet their toughest engineering challenges. And of course, being experts at Siemens PLM software helps us do precisely that. On the software side, here are the Siemens product lines that we use and can help you out with, whether through license sales and technical support, or by training your engineers to use these tools to their fullest capacity. I'd also like to point out that ATA developed the official NX Nastran training materials and is the preferred training provider of NX Nastran in North America. Now, many of you have already seen our software website. Here's the place that you can find product information, links to download free trials, info on our upcoming training classes, and more. For existing users, you'll find a link to our hotline and an ever-expanding array of free resources, including white papers, training videos, tutorials, and APIs. I invite you to check out these resources after the webinar, but without further delay, I'd like to turn it over to Curtis for the main event. Curtis, take it away.
Thank you, Jonathan. So today I'll be talking about principles and workflows for product and manufacturing information using NX. I'll begin our talk by giving some background, some general background about PMI and model-based definition. So product and manufacturing information is more commonly referred to simply as PMI, and these are non-geometric attributes used to visualize product definition within a 3D model. The major elements of PMI include geometric dimensioning and tolerancing, text annotations, surface specifications, material specifications, and data markings. These are probably the most common categories, although there are some other elements of it. Often, PMI is used interchangeably with the term model-based definition, or MBD, but it actually fits into this larger concept of model-based definition. Model-based definition generally comprises a CAD model, PMI, component and assembly level material, engineering configurations, requirements and specs, and design intent. So for any of you who are familiar with the Siemens product Team Center or other PLM systems, probably you'll immediately recognize that all of these things are integrated into the Team Center experience. The idea of model-based definition goes pretty far back when people were still making drawings by hand on drafting tables. It was more formally standardized into ASME Y1441 2003, Digital Product Definition Data Practices, and more recently updated in 2012. ISO and JADA have MBD standards as well. The aims of model-based definition have always been to improve productivity and reduce time to market, and to replace 2D engineering drawings used for all of the activities between design and putting a product on the shelves. That might include manufacturing, inspection, and documenting and archiving design data. Model-based definition can establish the 3D digital data set as the true design authority for a product so that we can go direct to manufacturing. We can also go direct from the 3D model to other potentially time and labor-intensive activities, such as tolerance analysis, inspection via coordinate measuring machine software, and other quality control processes. Even with all the other elements of model-based definition, a substantial portion of this aim falls squarely on a CAD model with its embedded PMI to provide all the dimensions and tolerances, surface, material, and finish specifications, and any additional manufacturing and inspection information that you'd conventionally find in the 2D drawing. For good reason, a discussion of the benefits of PMI is generally centered around manufacturing and related activities. With a comprehensive digital data set embedded in the 3D model, in other words, the absence of 2D drawings, that's clearly a major segment of the product development process that can be shortened and improved. Honestly, I don't really see it as an easy sell to get PMI and model-based definition infrastructure fully integrated into the supply chain. There are just too many moving parts there. However, I think there are clear advantages at intermediate points along that path. So to rephrase that, I wouldn't say that it's impossible or that it will never happen, but that instead of trying to convince everybody to jump all in, making measurable steps towards that ultimate goal of eliminating the 2D drawing and establishing 3D digital data as the true design authority has a lot of advantages as you move along that path. An additional perspective that I'd like to add is that without downplaying the manufacturing side of things, PMI can also be used to speed development upstream of final product definition and manufacturing. It can be used to capture and archive design decisions and intent and eliminate many extra steps in the documentation, communication, and review cycle. For highly engineered products, the time and cost spent in design and development stages is substantial. PMI can be used to reduce mistakes, miscommunications, and rework, particularly across large teams or multiple organizations. So I'd like to segue to the next part with an analogy. Think about mountaineering. You probably noticed if you walk into a store like REI that when you start up into a hobby such as mountaineering, you have this ultimate goal to reach the summit, right? But you need to invest a lot of money up front on specialized gear, clothing, provisions, and until you reach that summit, there's really no intermediate position that will be very satisfactory or fulfilling. On the other hand, when you set out to run a marathon, all you need is a really small investment, maybe just a pair of running shoes. And intermediate successes, such as running a 5K, a 10K, then a half marathon, the requirements and effort grow in proportion to your next milestone. But each success also brings its own gains, such as increased fitness, stamina, strength, flexibility, etc. So I always think of implementation of PMI into your team's processes as more like the runner than the mountaineer. Even though the end goal may be the elimination of all 2D drawings, there are still very big gains along the way, and the initial investment or overhead cost is very small. You really only need a small amount of training, the right license bundle for your CAD software, and you're already taking that first step, maybe what I'd call running your first 5K. It also takes people in your organization and within your supply chain to kind of spearhead that effort, to be the explorers and the visionaries that want to make that a reality. But again, that initial investment is quite small compared to the substantial advantages that you'll gain along the way as you proceed towards that goal of eliminating 2D drawings and streamlining your process. So I'm going to be doing a demo in just a moment, but before going there, I'd like to share a few notable examples of how PMI can be used in the design process. So a first example or scenario is a rough concept sketch with designer's annotations. So these are called notes in NX. Basically, we've got these PMI notes and a rough concept sketch, and the designer, or at least the person with the concept, is looking at an initial CAD model and adding notes. There may be a two-way dialogue, right? The annotations may be statements, they may be questions about how they would like this to look. And this is really at the requirements development level, or somewhere just upstream or after requirements where the product is starting to take shape. Capturing this in a CAD model means that you have the conceptual models and the annotations, all of the designer's intent, and some of that requirements development, thought process captured in one place where it can be archived, it can be discussed, it can be shared among other development partners in the organization and outside of the organization. That's one simple way that you can use PMI. The next scenario, again, still has the conceptual design, an early CAD model, but here I've added some dimensions. They're probably not final dimensions. They're probably based off of some market research or some initial designers' concepts or notions. Some other elements that you can add in NX besides dimensions and notes, you can add URL notes. So these are specific to web pages. When you right-click, you can open the URL for that selected note. So again, it's just adding a little bit more layers to this design concept process and storing those in a way that anybody who has access to CAD model or a lightweight 3D representation of the CAD model that the PMI is associated to can see these and be included in that development and communication process. The next scenario is when we get further into the detailed product design and we've added some live dimensions. I don't think, a lot of people might think this is a simple thing, a CAD model with dimensions on it, but really, even though it's somewhat trivial to do, it can save really a substantial amount of time. Think of all the time spent documenting and communicating design details to stakeholders, whether it's within your team or organization or outside investors, customers, or manufacturing partners. Here at ATA, when we're getting ready for a design review, we'll often take screenshots of a model and add dimensions or annotations to the images. But if we instead are adding the annotations before the screenshots, now these annotations are live and directly associated with the latest design revisions. That means when the design changes right before the review, you don't have to go in and make sure that all your annotations are up to date. A customer, an executive, a design partner might be interested in critical design dimensions, and if you're using PMI, you can be assured that the picture they're looking at and the dimensions line up, and they're the latest information that's associated with that model. If you're using PMI, you can also avoid the screenshots altogether, and you can do live demo so that you can create the PMI ahead of time based on what dimensions you think will be of interest to your audience, or you can create them in real time, and you can show and hide them as needed. And I'll show some of that in the live demo. At the assembly level, I have filters that show which component level PMI objects are displayed. So for example, part names might show up through those filters. We can add part ID, material specification, enterprise information, and other predefined notes that are available out of the box, but you can also create custom notes for you or your organization. I'm also showing how we can look at lightweight section views. And speaking of customization, the preferences for each of these PMI elements is defined using drafting preferences. So just like you can set up part templates ahead of time in your organization so that all of your drafting elements have a unified look and feel that meets your organization's policies and other templates that you have. You can also set up templates for parts that have the drafting preferences predefined so that all your PMI notes will follow the standards that you use within your organization. There's a few other preferences special to PMI as well that aren't drafting preferences. So I'll mention a few. You can choose if PMI objects are obscured by geometry or if they show through. You can, because the PMI objects exist as 2D objects within a 3D space, you can select whether the letters and numbers automatically flip their reading orientation when you rotate the model. You can choose default planes to associate them to, etc. The last example I'll show is how we can create drawing views with important product notes and manufacturing information during the design process. I'll talk about model views when I get into the live demo. But basically, PMI is associated with model views, and those model views can be imported at the time that you create views in your drawing, and you can import several or all or some of the PMI types from each view into your drawing so that the designer can produce the views and the critical annotations with those views ahead of time, enabling the drafter to bring those directly in without having to guess what the designer's intent was for those critical dimensions and notes. This can really streamline the drafting process, eliminate any mistakes or rework or miscommunications that might happen between a designer and a drafter. And then at the end of the day, the drafter is responsible for, instead of guessing at critical dimensions, simply going through and populating some of the other more standard dimensions and tolerances into the drawing views. You know, I talked about PMI and model-based definition ultimately being a means of eliminating 2D drawings. So why am I talking about the 2D drawing here? Well, the 2D drawing is not going to go away immediately for every organization. So for those organizations that still feel like a 2D drawing at the end of the day is important, whether it's a hard copy or a digital file like a PDF, the PMI features in NX allow you to get the best of both worlds, where you're using the PMI to capture design intent from the designer and create model views and any other process that the designer should be involved in, but then the drafter at the end of the day has access to all that intent and can then populate the rest of the things that would be standard in a drawing without the designer having to be involved in all of the steps of that process. It really has the promise, before you eliminate 2D drawings, to shrink that process or streamline that process, so you're eliminating a lot of the redlining and some of the other things that come with the transition from a 3D part to a 2D drawing. So I'll go into the live demonstration now, and there's 4 areas that I'm going to talk about. I'm going to talk about getting started, and that includes model views and PMI. I'll talk about lightweight section views, which are a really powerful feature with model views and PMI and NX. Turning sketch dimensions into PMI, and then I'll talk about some other user tips as well. Okay, so getting started with PMI. So I have a CAD model here, and I want to draw your attention to the model views. A lot of people kind of think of the model views simply as quick ways to snap between different orientations as you're viewing the model in 3D space. But they're really important for using PMI. And as you start using them and getting familiar with how they work, you'll find that you can save a lot of time if you use model views, take advantage of model views right up front when you create parts and assemblies, because it will later, as you visualize a part from certain angles, it will simplify how that part is laid out, whether it's on a 2D drawing or using the 3D model as the design authority. If you have the PMI addition in your license cluster or license bundle, go into application in the ribbon here and you turn that on or off. So you can turn on PMI, and now it opens up a new tab in the ribbon where all the PMI tools are located. So to activate a model view, you simply double click on it. You can right click on it and make it the work view. Once you have a part rotated a certain way, you can create new model views as well. So you right click on model views and add view, and it will save a view, and you can name it whatever you like. When we start creating PMI elements, the current work view is where those elements will initially show up. So I'm going to actually create a new model view that's just like my top view here. And that's where I'm going to start as my work view and create a few PMI elements. So very similar to drafting, you have different kinds of dimensions and some notes, weld symbols, center lines, a lot of the main stuff that you'd recognize from drafting, but they have just a little bit different functionality when you create them in the 3D model. So I'm going to go ahead and create a radial dimension first. Because this is a 3D space, it's not automatic what plane it would be associated with, or the PMI elements are going to be associated with. So there will be a default plane orientation that's selected for you, but you can choose where you want the PMI element to be associated or placed. I'm going to choose this circle here, and it's going to place this on the XC-YC plane. And I choose where I want to place that. And you can see that the XC-YC plane here happens to correspond with this top face. So you can rotate it, you can see that in that model view it's clear to see, but if you rotate it at different angles, you know, that 2D element rotates like a 3D object. I can add a center mark to this circle as well, and it automatically places it at what's called the model view plane, but I can place it at any plane that makes sense for that center mark. So now I'm going to do a linear dimension and illustrate how to do associated objects. This linear dimension, I'm going to dimension from this face, and place that. And you'll notice if I click on a PMI element, it highlights the components of the part that it's associated with. And there are default components of the part that a dimension would be associated with. Obviously, the face is off, which I dimensioned. I could have just as easily dimensioned the edges or the corners, but I chose to do the faces here. When you're doing a 2D model, you don't really get that distinction because you can't see into the part, into the plane of the part. It selects the edge or whatever it is that you dimension off of in the 2D part, and you don't really know which face it's associated with. So the standards require that you can select and highlight objects that you want that dimension to be associated with. I can also associate additional objects with that dimension. So if I wanted to select other faces to indicate that those are also associated with that dimension, I can add those. And when I select on a PMI element, all those faces will highlight. So again, on a 2D drawing, this might not be that interesting or useful, but in a 3D part, someone who's inspecting this part can see what the designer intends in terms of which faces or which elements of a part are going to be associated to a dimension, or maybe more practically a note, a surface finish, other things like that. So I talked about model views, and now I'll show you here how the model views contain the PMI elements. There's also a PMI node, and all of the PMI elements in the part are going to be in this PMI node. but they're also going to be stored by requirement in at least one model view. Now, if I choose the center mark and right-click on it, I can change its display. I can make it to be displayed in all views. And now you'll see that every view is going to have that PMI element in it, whether it makes sense or not for that particular view, even if you can't see the center mark. So I'll go back to the top number 1 is my work view, and I can change that back to just in view instead of in all views. And now it's simply in this view. I can also choose display in views with little ellipses, and it gives me some options of where I want to choose that to associate. So now it's in select views based on what I've chosen. I can turn it on and off. It turns it on and off in all views. Likewise, I can access those down here in the PMI node. So there's a lot of ways that you can create these PMI elements and make them associated with certain views. And if you think of the 2D drawing, you might think how the views are going to be laid out and where you want dimensions to be shown or repeated in different views. But if we're getting away from the 2D model, thinking about the 3D model and the 3D digital data, the design authority, there's also a lot of reasons why you might choose dimensions to show up in certain views. There might be a view for a documentation, for a design review, and there might be certain views for inspection. So you could choose which PMI elements make sense to be associated to each of those views. Okay, next thing I'll talk about are section views, and I'm going to stay in this model. So now I'm going to create a lightweight section view. This is a section view that you can use later on, both in the 3D model and in the 2D drawing. If I right-click on a model view and choose Create Lightweight Section View, it's like any kind of a section tool in NX. It allows you to choose the plane that you want it to do the cutting on and several other properties or parameters for that particular plane. And it's going to create a new section or a new model view with the name that I specify. So I choose a plane and I choose which object is going to be cut. Hit OK. And now I have this new model view. And I don't really want it oriented like this. It doesn't make sense. I want it oriented like this. So I'm going to change the orientation, right-click on that model view, and hit Save. And now I can jump back and forth from other views, this section view. I can dimension on this section view just like I would dimension on a section view in a drawing. I think that the section views created here simplify or are easier to create and work with and dimension than section views at the drawing stage. So that by itself saves a lot of time by doing the section creates here and dimensioning to those. So we talk about, using this PMI as a tool for replacing drawings. Some of the images that I showed earlier show these 3D objects with dimensions all over them. And the reality is that if you're going to use PMI and rely on the 3D model as the design authority, then you don't really have to dimension everything because your 3D model has the dimensions built into it. You've designed it and you've CAD'd it up to those dimensions. So going through and dimensioning a part becomes redundant. The PMI then becomes very powerful in that you use it only where you might have out of the ordinary tolerances. So you'd have, like on a conventional drawing, where you might have general tolerances unless otherwise specified. When you're using PMI, you can assume tolerances meet some general unless otherwise specified values, and only those that are specified or out of the ordinary would be called out. So I could choose which dimensions have special tolerances and call those out and leave all the other dimensions blank. You get a reduced dimension drawing or a reduced dimension model because all the dimensions are automatically built into the 3D model. But like I've shown, adding tolerances or changing the tolerance style or type is very much uniform with how you do it on a drawing if you're familiar with NX drafting. Double-click on the PMI element, and then you can change and update your tolerance style, the values, even some of the other display elements of that PMI component. You can change all of your text styles, add appended text before, after, above, and below. So all of these features are something that's familiar to someone who's already doing drafting, and therefore the training and the learning curve is very shallow to get into and learning how to use it. The next thing I'm going to show is using sketch dimensions and converting those to PMI. So I have this part or this sketch that I've created, and if I open the sketch, I have this model with some constraints, some relationships between the different elements, and I can right-click on a sketch dimension and choose it to be displayed as PMI. So I'm going to do that now. And if I right-click on it again, you can see it's a toggle type switch, so that component is recorded as being displayed as PMI. Now, when I finish the sketch, those sketch dimensions are showing up as product and manufacturing information elements. And they show up in the work view that I was in when I went through that process. I can still treat them like PMI. I can also turn them on and off from this level. Well, once I turn them off, I have to go back into the sketch to turn them back on. So this is great for identifying key dimensions. Again, maybe it's for communication within your organization or to one of your manufacturing partners. It might be that these are the critical dimensions for you as you go forward designing a part, and you want to keep track of what those are. You can also edit those in real time. So I can go into my expression editor and I could change a dimension. So I'll change this 35mm dimension to 40, apply, and it updates the PMI. It also updates the sketch. So it's similar to going in and changing these parameters. I can do this expression editor change on the sketch with or without displaying the values as PMI. But when I have the values displayed as PMI, I can quickly see other things that might update, especially where I have relationships. So I've defined, this angle here is actually half of this angle. So I can go in and I can change this from 60 to 64 and apply, and you can see that the 32 updates to 64. If I want to communicate this to someone that there are certain things that they can change and certain things they shouldn't change, just like in a drafting environment, I can make a dimension a reference dimension, something that's not really a driving dimension, but instead is automatically updated by others. There's a lot of ways that I can use this convert or display sketching elements to PMI as PMI. I'll note that this is a relatively new feature, and it's something that NX has added, the NX developers have added, so that whether or not you have the PMI license bundle, you can display sketch dimensions as PMI. And then it requires, to do the editing beyond that, it requires the PMI tools to be added in to the license bundle. So I'm going to show another user tip. This is just an arbitrary part that was created using a spline. So I have a spline curve that I've extruded. And some people notice that if I want to dimension this spline, do any kind of dimensioning on the spline, for example, I kind of want a distance across the spline. It's not really possible to grab a point on the spline without having created a point ahead of time. So it's just a function of the PMI tool and the spline tool, or the way a spline works. It's not very easy to do that. But there's a cool little workaround or feature related to that. If I create a lightweight section view, and I've already got a plane selected where I want to create that, now I can go in and I can dimension off the corners of that. And I'm going to choose which plane I want to dimension off of or place those. Place the PMI element. And now, when I go into any other view, I can display that PMI in that view. Even though I couldn't really create the PMI in that view without the lightweight section, that PMI element or that dimension is visible or available in any of the other views. It seems like a little bit of extra trouble to go through to do this, but one important thing is that if you want a dimension on something, an arbitrary curve like a spline, it's important that you know what you're dimensioning off of. And so if you were creating a drawing, you would very likely create a fixed datum plane and a section view of that element anyway, so that you could make sure your dimension was not grabbing an unintended part of the spline to do the dimensions. And here, we can, in a very controlled way, create the plane that we want to dimension across, and then add that dimension, and that dimension is now available to us downstream for any purpose that we have. And there's a lot of industrial design companies that have splines that define the outer dimensions and the outer envelopes of their parts. And so this is something where they might want to look at just broad dimensions and communicate those to a manufacturing partner, and this feature allows that to work that way. I'm going to open up an assembly part and show you, as my last demonstration, just a little bit about how PMI fits in the larger context of an assembly. So this assembly doesn't have any PMI elements by itself. But if I go into one of the parts and make that the work part in the context of the assembly, you see that I do have some PMI in there. And so one way I can view that is by making the part of interest, the work part, and I can go through each of those model views and show, visually check what the different PMI elements are for that part. But I can also create what's called an assembly filter, where it brings in selected PMI elements from the parts in the assembly. So I'm going to go back to my assembly, make it the work part, and under model views, there's this PMI assembly filter. So I'm going to add or feature. So I can add a filter, and I can choose whether I want to do it by model view name. So any model, for example, the front view from any part in the assembly, it'll bring all the PMI associated with that model view. Or I could go by PMI type, and it gives me several options to choose from. So I'm going to choose part identifier, material specification, and I'm going to do all components and hit OK. So now I have this filter, and I can go to my model view. Sorry, I can go to the filter and I can apply it to the model view that I want it added to. So now I'm seeing that material specifications and part IDs for all the components that have those PMI elements already defined and placed show up at the assembly level. And what they are is we're looking from the assembly level kind of a window into the individual parts, and we're filtering what we want to see for each model view. So they're not separate entities. There is a way that you can also make copies of PMI and bring those up to the assembly level, and that's used, there's a Pmi Wave Linker. If you're familiar with wave linking, Pmi Wave Linker is the same process. It brings an associative copy up to, from a component level up to the top level of an assembly. And that is an associated element, but it's another part. You're not just looking down at the PMI in the different components when you do that. Other things I'll point out, but won't really walk through in any detail, are Pmi Search. So you can search for certain types of PMI. For example, I could search for PMI of a certain tolerance type, or I can filter by dimensions with tolerances above a certain amount or below a certain amount, and identify those, and I can produce reports that list out the things that I've searched for that Pmi search. You can imagine if you have a part that has some very tight tolerances and you want to determine how to make that part a little bit cheaper to make for the benefit of you and your manufacturing partners, for example. You can search to find out what's driving up the cost in an assembly or in a part. And a manufacturer could search and identify where the tolerance has been specified and what kind of tolerances there are. So that's another feature of the PMI tools in NX, is to be able to do these searching and reporting of PMI elements. Another one, I showed it briefly, is this arbitrary region, or this Pmi region. And so there's a region tool where you can choose a face and you can create a circular region, an annular region, a cylindrical region, or an arbitrary region. And it will wrap that region around tangent faces if you select. So this might be for specifying like knurling or a silkscreen label or other surface or finish, surface finish or material specifications. There's really just a wide variety of things that you can do with a few simple annotation, region, and dimension tools that satisfy basically everything you'd ever want to put on a part on a drawing. And now you can do it in the 3D model and get that much closer to eliminating the drawings completely, being able to capture design intent at various stages of the development, and hopefully streamline your processes, eliminate rework, miscommunication, errors, and really make clear what the design intent is and make that the authority for the part from concept all the way through production. So I'm going to go back to slides for just a minute more. Kind of recapping, or by way of conclusion, I return back to the runner who's made a series of balanced investments of time, effort, and perhaps some money training along the way. With PMI, the reality is that as you start to use it, others at your organization and perhaps within your supply chain will see the benefits of it. And before long, you'll have your whole team making progress and getting faster as well. I think that the overhead associated with implementing PMI into your day-to-day processes is extremely small, and the NX toolset makes it quite easy to create and work with. At the same time, there's a lot to gain by it. I believe that every stage in the product design and manufacturing process can benefit from the additional information that can be captured and stored within your digital models. I'd like to thank all those who attended today. I understand that the recorded webinar and slides will be available on our website a few days from now. If you have any questions, I'll take those now, and you can also always follow up with any questions you have later by contacting ATA through our software services website or Jonathan or others on our team. Thank you very much. Any questions? Jonathan, did you have anything else you wanted to add before we close this one out?
No, I think that seems really good.
Great. Well, after you've had time to digest it, if you have any additional questions, don't hesitate to contact us at ATA. Thank you very much.